let me give you a little bit of a lecture. Let me see where you guys are at. So the whole point of that worksheet is to try to make you understand that symbols in mathematics are just shorthand for questions. We don't want to write the whole question out for every problem, so we create a symbol that embodies a question. So this kind of problem here is easy because you don't even realize you've already internalized the question it asks. The question this asks is, what does it take 2 of to multiply to be 49? Of course, the answer is 7. This one asks, what does it take 4 of to multiply to be 81? 3. It takes 4 3s to multiply 81. So see, so this symbol, it's unfortunate. I tell you where it came from. It came from some arcane decision to use new Latin based off of Greek and all this kind of crap. They could have just used an actual symbol, like the square root symbol. It would have been a little bit better. So one thing that throws students off about logarithms is it's got the freaking word log in it, which is really different from anything we've ever seen before. But it's a symbol just like this is a symbol. Right? You should probably think about why the shit is it like that? Where'd that come from? Well, they just decided that would be the symbol. Because somebody did something weird and it sort of looked like this, and they said, let's just everybody understand that's what the symbol means. And everybody's like, sure. And the one guy that didn't like it, they killed him. So now, this symbol, if I see log base 3 of 81, this, I know the power, I'm looking for the base. Do you see that? 3 to the 4th is 81, so the 4th root of 81 is 3. Here I know the base. I'm looking for the power. That's the question that this asks. So logarithms are not difficult as long as you have a way to figure out what power. So the answer to a log will always be a power. So 3 to the what is 81? Well, 3 to the 4th is 81. That's how you figure it out. So what if I said log base 2 of 1/4? Like, what do I raise 2 to make it 4? So the second power. And then how would it flip? Negative, there, see? Negative 2. Why is it negative 2? Because it's got to become 4. That would be squaring it. And it's got to flip. That would be a negative power. That's how you attack this problem. Is you realize that log base something means what power does this need to become this. That's all the question. That's the question. So if you don't even know what the question that the log is asking you, how the hell can you work any of these problems out? That's where students normally are. Either they totally get it, because it's not that difficult work to do, but it is kind of difficult to get over that this is a symbol the same way that this is a symbol. It's a freaking word. Oh well, it's a symbol. Have you ever heard of any trigonometry? They got sine and cosine and all that stuff. So you got sin of something, 45 degrees. This is a symbol. The same way that's a symbol. It means something. It actually means ratios of the sides of a triangle. That's all trigonometry is. I'm not here to teach you trigonometry. But there's another example in mathematics where the symbol is not really a symbol. It's a freaking word. Right? So that's one thing that gets people going. But hopefully some of you guys realize this isn't that big of a deal. What's log base 2 of 16? So what are you asking yourself? There's a couple different ways you can phrase this question to yourself. How many 2's multiply to be 16? Or what's the power that 2 needs to become 16? They both mean the same thing. Yeah. Because 2 times 2 times 2 times 2 is 16. So it takes 4 2's. You guys get that? Don't let that be difficult. It never can change. The logarithm has to mean, this square root symbol can't suddenly mean something else. Right? Now that's a 4th root symbol. It means basically the same thing, but we put the number 4 there so I know I need 4 of the same thing. And here I need 2 of the same thing.
Right. You said what you said at the beginning again, I'm sorry. So you said it, the log 2 to the 16, like how many, what you said, somebody says
so again, it's on that paper.
Okay.
A couple times. How many 2's multiply to be 16, or equivalently, what is in that? I had a lot of cough there. So how many 2's does it multiply to be 16, or what power does 2 need on it to be 16? If you think about it, so it takes 4 2's to multiply to 16, which means 2 to the fourth power is 16. So that's why the two questions you can think of are the same. It's just up to you to figure out what makes more sense. How do you want to internalize that question? So how would you even begin doing this one? Consider what the question is asking you and then come up with a strategy based on that question. What is the question asking you?
How many sevens does it take to make 343?
So what's a smart way to start this off? Sure, but what are you going to do in the calculator? You don't need a calculator for this, right? What's a smart way? So some number of sevens multiplied be 343, or this can't be done by hand, right? I mean, hopefully you understand that I'm picking number. If that was a 15, screw it.
Right.
I would know it'd be a little less than 4, but that's all I know. What exactly? I have no freaking idea. Right? So I'm picking these numbers very carefully right now. So what do you think you should do if I'm really asking myself how many sevens multiply to be 343? What's a really good first step?
Is it even divisible?
Yeah, maybe
Can
try
this be a prime
to divide this by 7. Yeah. I mean, so knowing what the question is leads you down, what can I attack this with? How can I attack this? That's how math works. The people that say, I should be able to look at this and tell the answer and I can't do that, well, that's bullshit. Right? That doesn't mean you don't know math. That means you don't know what you're supposed to do with it. I'm not supposed to be able to just tell. Now, me, I can tell because I know this number. But that's just because I've done a lot of freaking math. Right? So if I didn't know this number, what do I start to do? Is start to break this thing down. Does 7 go into 343?
Yes.
Yes. 4, 28, minus 63, 49 times. And 49, of course, is 7 times 7. So it's 7 times 7 times 7. So what's log base 7 and 343? How many 7s does it take to make 343? 3 of them. The result is always going to be the number of these it takes to multiply to be this. Always. Which at the same time means the power, the 7 to the 3rd power is this. Because 7 times 7 times 7 is that. Maybe. Alright. So you guys try, if you haven't started this, go ahead and do that one. That first problem I already did for you.
And the D as well.
And which one?
D.
Oh yeah, D. That's right, I just did that one. It's hard to come up with a lot of these, but oh well.